Let's consider another problem. X plus 1 quantity squared over x cubed times 7 over 2 times x plus 1. So when we want to multiply these fractions, we just multiply straight across, giving us 7 times x plus 1 squared. And when we multiply across the bottom, we get 2x cubed times x plus 1. Now generally we want to try to do some simplification before we multiply things out. In this case, we notice that 7 times x plus 1 squared can be written as 7 times x plus 1 times x plus 1, right? That's what x plus 1 squared means. It means x plus 1 times x plus 1 over 2x cubed times x plus 1. Now when we start dividing the top and bottom by factors, we see that we can cancel out a factor of x plus 1. So divide the top and bottom by x plus 1, that cancels with that. And we're left with 7 times x plus 1 over 2x cubed. It is important to note that the x in this factor x plus 1 cannot cancel with an x from the x cubed. The reason being, when we cancel things, we're really doing division. So if you were to divide the top and bottom of this fraction by x, you would make this x go away, but then you would have a problem here. You would pick up a 1 over x, and you would now have a complex fraction, which is not simpler than what we started with. So this is as simplified as this problem can get, and if you want, you could distribute the 7 in to get 7x plus 7 over 2x cubed. Consider x to the 5th over 8y times 24y over 11x to the 4th. So when we multiply fractions, we're first going to multiply the numerators, giving us 24x to the 5th y. Then we're going to multiply denominators, giving us 88x to the 4th y. So to simplify, we look for the biggest number that divides both 24 and 88. That's going to be 8. So we divide that out, leaving us with 3 over 11. We have one more x in the top than we have in the bottom, so when we go through and start canceling them, we'll be left with 1 in the top, and our y's cancel out completely.